Hey folks, welcome to Sonpal podcast. Our guest today is Hiten Sonpal. Hiten is the CEO of Rise Robotics, where he leads the development of industrial technology built to improve how heavy equipment is powered, controlled, and scaled. Hiten, thanks for taking the time to chat.
Thank you, Krish.
My pleasure. We have a bunch of things to cover, plenty that I have very little clue about, so I'm kind of excited about the conversation. But before we get into it, a quick intro about yourself and what you do and your company to our audience.
So I'm the new CEO of Rise Robotics. I've been with the company for less than 2 years. I was brought on board by the founders to help take the company to its next stage of growth, primarily through commercialization of their technology. The company is affiliated with MIT. 3 out of the 4 founders went to school at MIT. And what we do is build a new kind of linear actuator that replaces hydraulic systems. We call our technology Beltronics. And what we've done is we've taken the oil out of hydraulic systems and replaced them with modern belts that are used by the elevator industry. And by doing that, we've ended up creating a technology that's 3 times as efficient as hydraulics, that's 3 times as fast as hydraulics, that's 3 times as durable as hydraulics, and is AI and automation ready out of the box.
Okay, thanks for that, Hiten. There's plenty you said there that I have to ask you. Before we even get into the topic, I'm going to educate myself a little bit more so I can ask you meaningful questions. For laymen like me, can you de-technicalize? There's no such word, but I'm just going to throw a word out there. What you said there, and the way I best understand this typically is, let's start with who your customers are. You know what I mean? That'll give some idea to who's buying it, and then figure out how they are using it, and then I'll ask you who your competitors are, so that kind of goes the whole circle and gives us a good context to where you folks are. So let's start with your customers.
Yeah, our biggest customers currently is the Pentagon. So we work with the Air Force and the Army, and we're developing hydraulic-free solutions for them to help improve their readiness and reduce the logistical footprint that they have to deal with in field. And then we recently started commercializing our technology, and so our first commercial sale was at the second half of last year, and we're running a pilot in the oil and gas sector, which has an $11 billion TAM, where we're taking hydraulic natural gas pumps and converting them to Beltronic natural gas pumps, which are fluid-free. And once we've done that, our next step is going to be into oil pumps, which is also a very big market for us. Further down the line, we're looking at construction, forestry, maritime. We have a lot of interest from heavy industry in general, but our 2 primary customers right now are the Pentagon and the oil and gas sector.
Thank you. We're going to talk about React development for the next 30 minutes. So Krish doesn't come across as stupid here. No, I'm just kidding. This is going to be super exciting. The less I know about a topic, Hiten, the more excited I am. And there is no dearth of topics that I know very little about, so which is great. So I was just pulling up your company as you were talking as well. So there's a few different products. It talks about Beltronic cylinder, railgate, super jammer, and whatnot. We'll go into that, but you know what? I'm going to jump into the topics. You mentioned your customer. They got plenty of money, right? They got plenty of money. So it's one of the greatest customers I think anyone would want to have. Before we go into the topic, I'm presuming it's new enough, but do you have existing competitors? Like, are there other companies that are doing something along the lines of what you're doing?
We actually have no competitors. Our competitors in one way are the incumbents, right? Folks that are currently making hydraulic systems, and they continue to evolve them and make incremental improvements. But they've reached the ceiling of the S-curve in terms of what can happen with fluid-based actuation. Mm-hmm. And we have companies that sometimes think they are our competitors, but are more likely to be our partners. And these are companies that do make linear actuators to replace hydraulics, but they typically use screw-type technology. So they're taking a ball screw and they're rotating a screw to push it forward and backwards. Those companies, as I mentioned, have a potential to be our partners because the stroke lengths that they can push at are relatively small. The speeds at which they can move those actuators are relatively slow. And then the forces they can apply with that technology is also relatively slow. And so we have longer stroke lengths, higher speed, and higher forces than that technology. So we're very complementary to screw-type actuators. So just kind of that's a sketch, but basically we don't have any competitors in this space.
Thank you for making me feel younger. And here's what I mean by that. I actually feel 30 years younger, and I'm sitting in a class. A lot of what you're talking about here, Hiten, sounds more like quantum mechanics and circuit theory to me. I vividly remember sitting in those classes for like 50 minutes every 2 days, and I kept wondering, oh my goodness, I wish I don't ever have to do this for a career because I'm going to be terrible at that. But what you said there is super exciting. I'm going to do more reading after the podcast as well. So just to get a sense of what you folks do from a product and services standpoint. But this is as good a time as any. I want to use the next 45 minutes or so to ask you a bunch of things that and I'm sure a lot of our audience is excited to know about, but probably doesn't know a whole lot about. The topics, just to quickly socialize them, we're going to go with them in random order. Uh, Innovative fundraising, that's one of the topics. What building deep tech taught you about product development, how to bring hardware innovation into legacy industries, what startups get wrong about scaling complex technology. Now, all of them, each is as interesting as the other. Do you have a preference, or can I just pick one and go?
Pick anyone that you think would make sense, and let's go with that.
Okay, we're going to cover as much as all of it as we can. Let's start with what startups get wrong about scaling complex technology. Now, I run a startup myself, a software startup, but what you do is a different line of business altogether. So, but I'm still interested in knowing what it is. Let's start there, right? What do startups get wrong about building or scaling, complex technology?
So I spent a fair amount of my career at iRobot. Teams that I led there generated over $2 billion in revenue, shipped over 9 million units across 20 product lines. And we did a lot of deep tech product development. And one of the key insights for me was that when we were looking at performance in any one axis, as we tried to deliver that performance, the amount of effort it took, as you increase the amount of performance that you were delivering, increased exponentially. And that's true for really anything, whether you're trying to reduce the cost of something or whether you're trying to improve a certain performance of something or the runtime. Every increment causes more and more work that you have to do. And when teams try to take on multiple aspects of deep tech development where they're trying to cut cost, improve reliability, increase runtime, increase durability, right? Where they're trying to do all of that at once, all those exponentials start to add up very quickly. And at some point, the problem goes from being tractable that you could solve to something that's not going to be tractable inside a company before the next reorganization. Like most large companies go through some sort of reorganization every 18 months. And if you have a project that's languishing, it's going to last maybe one reorganization, but it's not going to last two. So, in 36 months, your project is going to get canceled if you aren't making substantial traction. And actually that also applies to startups. Whether it's a large organization or not, typically you have 18 months of runway, you need to hit some milestones. And so my key insight has been to really help the engineering team understand that they don't have to solve all of the problems, that they really only need to pick 3 key problems that the customer doesn't have a solution for, or that the customer is really crying out for innovation and improvement. And if they can focus on those 3 things and put them out, they're going to have a market, they're going to have a successful product. So my key insight has been, how do you cut down, think of a spider chart, right? With all these axes, how do you squish that spider chart down to something where the area inside the spider chart, which is the amount of money you have to spend, is something that's tractable and can be done in a certain amount of time?
Hiten, I'm going to take software as an example because that's pretty much what I do. And I'm going to extrapolate that because, a lot of these questions are not completely off base, whether it's hardware or software. So where it makes sense, please answer those. Where it doesn't, tell me, Krish, that doesn't make sense, and I'll go on to the next one, right? So let's say based on what you just said there, you want to identify those 3 important problems. Let's say 3 as a number. You're like, hey, we've got 18 months of runway before we got to make some changes, adjustments as you start getting feedback. But you got to start with those 3 things. But those 3 things, are they going to stay consistent during the course of the next 18 months? Because the micro and macro conditions don't stay intact for 18 months. They hardly stay intact for 18 days these days in the world of AI and micro and geopolitics and whatnot. So how do you take 3 problems and the turnaround times actually? part of what I also want to ask Hiten is if it's software, the turnaround times are different. You know what I mean? You could spend a weekend and do something fairly significant, but I'm guessing when you're doing robotics, and correct me if I'm wrong, there is a lot more money involved here. So the time to ramp up is going to be nowhere near just writing a library or a framework in software, for instance. So, how do you manage those three important things? The world changing on a daily basis, AI making significant impact. We'll talk about that a little bit if we get a chance for sure. So, how do you manage that, and how do those three things change? Do they even change consistently, and how do you manage those changes so you can actually achieve meaningful targets?
That's a great question. I think that a lot of patterns in hardware and software development carry over. I actually paid my way through college writing software during the internet boom. So I have a fair understanding of the software development patterns and how similar they are to hardware development patterns. I mean, some things have gotten easier in software. For example, building and releasing happens, instantly, right? Which for software also used to take a long time
Right.
ago, a while back. Um, so what I'll say is that the 18-month time frame that I picked is directly from the consumer electronics industry. If you were just doing a pure SaaS-based thing, maybe it's not 18 months, maybe it's 9 months. If you're doing something where there's a lot of research happening, like in AI, maybe it's 6 months. And if you're in, say, heavy industry, maybe it's not 18 months, maybe it's 24 months, right? So the time scale does change a little bit here and there, but it needs to be sized to the rate of change in that particular industry. But the key tenet still holds, which is, can you find out what your customers' pain points are, and can you deliver it in a time frame before the organization loses patience or you run out of money, right? And so if you're running a AI company where even the VCs are giving you, less than a year's worth of runway because they're like, hey, you should be able to use AI to write a lot of your code. So I'd like to see a prototype over the weekend, right? So, the tempo is a little different, but it still comes back to what are those three things that you're really focused on, those three pain points where you can innovate and you can go out and you can get a customer. Now, to your point, the world is changing and it's changing quickly. And it is possible that while you're pursuing those three pain points, something shifts, right? But you really want to keep up that tempo and focus on those three things so that if one of them changes, you still have two that you're working with. If you were trying to solve for 5 or 10 things, right, you could have a third of them change and all of a sudden a lot of your work is thrown away. So this concept of like focusing on a few things and getting them right, I think works across sectors, across industries, whether it's software or hardware.
As we talk about these topics, Hiten, I'm going to probably switch back and forth because I want to also understand the core of what you folks do. And it's again very exciting because it's very different from my usual day-to-day job, for instance, right? So I was just looking up one of your products, which is the Beltrolic cylinder. And one of the things that picked my interest or caught my attention here as you're talking, it says choose between Raspberry Pi and NVIDIA Jetson options. So I think I have a question there, just to pick your brain with that. So NVIDIA, now we usually talk about AI, no conversation is complete these days without AI being part of it, whether it's at work or whether it's at home over dinner tables, right? Because it makes an impact across all facets of what we do as people these days. So I think it's fair enough to switch to this really quickly, NVIDIA Jetson. So do your products, I'm just assuming here, actually have like these models inbuilt into your physical products? In other words, as opposed to us software engineers using those LLMs and those models separately, I'm just completely imagining this. This could be nonsense. Does NVIDIA does that software become part of your actual cylinders where that LLM or data models, they're sitting in your hardware devices?
No, our any AI models would be sitting outside of the devices, right? The reason why we offer the choice of a Raspberry Pi, which is an easy thing to acquire, and most engineers should have one that they can hack with, versus a Jetson, is that if you're already doing something very sophisticated, then you might as well use the hardware that you already have. And a lot of engineers are working with Jetson kits to build AI models. So the models will stay offline; they don't go inside the cylinder. What our cylinders do that's different than hydraulics, which makes them very easy to build into AI systems, is that a hydraulic system has bang-bang control. And so you open the valve and, the hydraulic fluid moves and it gets to the other end, and you might have a stopper or something like that, but you really don't have multi-position control. And our systems out of the box provide you with multi-position control so that you know the orientation of the actuator, you know the forces it is experiencing, and you know the position of each actuator. So and what that allows you to do is to build a digital twin out of the box. And once you have a digital twin, then you can model that in simulation, and you can do things like teleoperation, which a lot of autonomous systems need anyway, because you have this long tail of corner cases that it takes a while for the AI software to get to, the AI models to get to. And so you need that capability out of the box. And to do that, you need a digital twin. Imagine an excavator that you've turned into an autonomous system. You are going to need an operator to check in on that. Recently, there was a testimony on Capitol Hill by Waymo where they basically revealed that they were using operators in the Philippines and in the United States to get the Waymos unstuck. They're not real-time driving the systems, but
I know what you mean. Yep. No, I saw that. Sorry, go ahead. Yep, I'm
Yes.
following you there.
Exactly. And so the only way they can do that is they have a digital model, right, virtually of what the car is doing, what the car's environment is, so that they can pull the car out of that situation, and they have full situational awareness. Well, with the hydraulic-based excavator, you don't really have that full situational awareness, because the situational awareness only exists when the operator's in the seat. They can see the bucket of the excavator, and they have to look at that to determine how much pressure to apply, how much hydraulic pressure to apply to that one actuator. They can feel the machine tipping over. They can hear the whine of the pump acting up as they're applying too much pressure. So they're closing all of these loops in their own head, and that's what requires a lot of training. But you take that operator out of that system and you put them remotely, well, all of a sudden they've lost the feel of the machine. And then you have to then give an AI system back that feel. And of course, you can't do it in a safety critical way, because there are all these corner cases. For example, if you lifted too much weight in the bucket of an excavator and you turn it sideways, you would end up tipping the excavator and creating a safety problem and also damaging a bunch of equipment. Well, if you use our technology, then you get a digital twin, and not only that, there's a safety policy you can implement that is not statistical like an ML-based system, but is actually calculated, where you can prove and do the math and say, okay, I'm not going to let you move the bucket of the excavator beyond 30 degrees to the side because you've got too much weight in it, and you're going to tip the machine. And so then the AI system is free to not worry about those things. And also when you're training the model, you don't have to train that safety case, test it, and validate it. So that's how we're able to provide AI systems the capability to actually operate these machines, because we give them everything that they need for a digital model.
There was a great example. Let me ask, do your cylinders make their way into an excavator in that example that you just provided?
Yeah, our smallest cylinder can push 2 tons, and our medium-sized cylinder pushes about 20 tons, and the largest we can build is about 40 tons, and then we can parallel them very easily because they're so precise, unlike hydraulic systems. So we can get to 80 tons, 160 tons, whatever is necessary for our customers.
Okay, cool. That's awesome. At least I followed through your example there, so hopefully my question here makes sense. So now you have this AI-powered device or equipment or component that becomes part of this excavator. Say, just to again ask a very simple question, compared to 3 or 4 years ago, Hiten, where there were such cylinders, but not maybe the AI-powered versions of those, were they making poor decisions? In other words, they were just doing the same thing again and again because they were just mechanical, right? They just did a job and they would do the job repeatedly, whereas the versions that you have today are going to be smarter because based on perhaps whatever the factors are. It could be the weather conditions, it could be the operator, it could be the weight of what it's lifting, that's making decisions differently and in real time from what the previous versions of those actually did in the past?
Yeah, I mean, because we have a black box inside each cylinder, the data is available for analysis later, right? And so there are many kinds of analysis that can be done. One easy one is, let's say you've got a specific customer that's buying 100 machines a year, very expensive systems. You can look at their data and say, our boom actuator is really designed to lift, call it 20 tons. And I see routinely you're only lifting 10 tons. right? So you're paying all this extra money for all these machines. How about we build you a custom system that can only lift 10 tons and we'll save you a bunch of money because you don't really need that. We put too much in there. And then we might find a different actuator that's being stressed too much. Like you're putting too much stress on the bucket, and that's why you have these failures in the field. We can see the data, and now we know exactly what to do to fix the data, to fix the machine so that it's stronger in that part. So the data allows you to do all kinds of analysis. Now, you can certainly look at the warranty returns, but that's later, right? So you run the machine for 5, 6, 7 years, and then it breaks, and you're hoping for it to have a life of 10, 15 years. Well, if you have the data early, you can see within year 1 or 2, oh, this thing is going to break here because there's so much stress being put on the machine. That's way more than we assumed. That's like just one piece of information. Another piece of information is, here's how much energy we're saving you because you moved away from a hydraulic system. And these are the energy credits you could claim if you would apply for a specific grant and say, we made this transition and here's how much we're saving. It's there are carbon credits available. So those are just two things. As you know, most autonomous systems haven't really scaled until they've become drive-by-wire, right? So there were autonomous cars or cars that had autopilot for a while, and people tried. Like there were all these companies like Motional working with gasoline-powered cars that were using, hydraulic brakes and things like that, and it really didn't start to scale for Hyundai until they started to, and for Waymo, until they actually switched to a platform that was drive-by-wire. So one of the core things we do is we convert all of those hydraulic systems into drive-by-wire systems, which is also foundational for the control that an AI system would need.
Wow. Okay, there's a lot to digest and unpack there. Let me, I followed most of what you said there, so thank you. So let's say, but that's not going to stop me from asking a silly question, but I did understand a lot of what you said there. So one of your, let's say an excavator has a lot of components, and one of the components is, say, the one we were talking about here. And you mentioned that, compared to, say, something like 3 years ago where it did not have the AI-powered versions of those, you clearly explained what those differences were. Fair enough. What I want to understand, Hiten, is, let's say there's 10 components. I'm sure there's hundreds of them, but let's keep it simple, right? 10 components that make this excavator comprises of. One of them is this. It is actually going out to the internet to make these decisions. But are these decisions made in real time, or is it gathering all of this data for decisions to be made at a later point where you make some adjustments or say, maybe tomorrow the excavator is going to behave differently, or is it actually reacting to these answers in real time?
Yeah, so you're always going to have a split architecture where you're going to want to put some policy at the excavator, so you're not at the mercy of the internet or internet connectivity, and have internet connectivity be the thing that stops the job site from being productive. So you're going to have a local model that does most of the work, and that'll be at the machine level, not inside our actuators. And then you'll want to have some remote operations, as we discussed, because there's going to be initially a corner case or many corner cases where you'll need an operator to step in. And over time, you'll be able to scale these operators so they're watching not just 1 or 2 or 3 machines, but they're watching 10 machines, and they can also work from home if they're not feeling well, because they have a full setup that is, virtual simulation of what they would be like in any machine. But then all the data that's being collected would then be sent to the cloud to refine the model. So every time an operator had to step in and intervene, you could have a software development team sort of key off of that and say, okay, what happened here? Why did the machine get unstuck? Is this get stuck? What did the operator do to get the machine unstuck? And can we train the AI to then also do that? And they'll find some cases where they can't do that, and they'll find other cases that are trivial and very easy to code in. And they can run the test in sim because they've gotten all the data. And then after they've tested in sim, they can push an update down where the model is run locally.
Wow, I've got so much to ask you, but if I took notes, I'm going to waste time, so I'm going to try and remember some of this. So I think you kind of answered one of my questions that I was going to ask you, which is not everything is entirely part of that cylinder that you talk of here, but you said there are some decisions that are made at the machine level, which is kind of what I was going to ask, because as more systems become AI powered, or more components, I should say, become AI powered, if the excavator had 9 other components that had nothing to do with what, say, you're doing, as hypothetically, each of them might have to make similar decisions. So 2 questions there. Then if the question even makes sense, I have 2 questions. One is, what kind of decisions are made specifically within each of these components? So when you build them, when you have the software integration, like, these are decisions that we've got to make because that impacts us entirely. and what are some decisions that you know that you have to defer or delegate to the larger system that your components are going to become part of?
So in my experience, you do not want to distribute decision making, because oftentimes when you're making a decision using a digital model, you are envisioning what the future state is going to be, right? And you're closing the control loop based on the future state you want to accomplish. And as a system is whatever the delta is between the current state and the future state, that's the loop that you're closing. If you have multiple different subsystems that all have their own expectation of what the future state is, and they all try to optimize for that, that would be global, and the local that would be local optimization, and I think you can run into trouble. So you want one AI system that is working with actuators that are all deterministic, and we provide deterministic systems, and then the AI system is running the speculative model on what the future state is going to be, and you want that, I think, centralized locally into the machine, and you want that to be iterated and updated over time. But you do not want to be pushing, I think, advanced decision-making policy down to different things. Like I don't think you want the wheels turning when the wheels decide they want to turn. You want the brain to decide when the wheels should turn.
Makes sense, because there won't be coherence otherwise, right? There could be conflicting decisions that are being made. Does that mean you have to be cognizant of the larger environment? By environment, I mean larger machines that your components are going to become part of? Because you know that there are some things that you don't want to make decisions on those, which means where your cylinder sits, that machine has to make the decision. So do you then, when you design this, do you keep that in mind, saying, you know what, this is where we think it's going to end up in terms of which machine, so we're going to have it make these decisions but not those other decisions?
Yeah, I think our goal is to build a very tight box around the operational envelope, because that allows us to do the validation and deliver a high level of quality. Once we start to think about the external environment that the machine is in, then the number of use cases and the tests that we have to run become very complicated. And so it becomes more challenging to deliver the high level of quality. So what we would want to do is say, here are the masses that can be attached to the machine. Here are the forces that the actuator can experience. Here are the different orientations in which the actuators can run. We might even look at the power source and say, what happens when you have a lot of power? When you don't have enough power, how are you operating? But that would be the full set of inputs that we would try to solve for. We wouldn't try to determine, for example, if there's gravel and beyond the gravel there's a ditch. Like, that would not be where the actuator would be responsible. We would expect a higher order AI system to run, say, a LiDAR and actually detect what's on the outside, and then turn that into decision making, and then let each actuator know, okay, you need to push here this much, you need to turn this wheel back this much, those sorts of decisions. We wouldn't want to push that at the actuator level.
How to bring hardware innovation into legacy industries? Let's talk a little bit about that.
Yeah, that's a great question. So one of the things we found out is that our biggest enemy, since we don't have any competitors, our biggest enemy really is inertia, right? And a lot of legacy industries have been doing things a certain way for a very long time. So their training internally of their employees is built a certain way. Their processes are built a certain way. They've optimized for the technology they have, for the market conditions that they've seen, and for the customers that they have. And so bringing change can be very challenging. And what I've found that works well is to identify customers that have a specific pain point that really bothers them, and to then go address that pain point. And that causes legacy industries to move, because they've been living with this problem for a while, no one has showed up with a solution, and then we show up and say, hey, we can solve this particular pain point. If we show up with something that's like, hey, this is better, really it doesn't get traction. It takes a while to build traction that way. So when I first joined Rise, there was a lot of interest from the engineering team here to get into the construction space. I used excavators as an example, and construction is an interesting market for us. It's large, but it is also slow moving. So as we started to look at where we wanted to put our chips, because startups have limited resources, and so you want to make the right bets, we wanted to find a customer that had a really big pain point. And what we discovered is, in the oil and gas sector, because hydraulic systems are running 24/7, any kind of durability problem, any kind of efficiency problem, any kind of downtime is substantial amounts of pain. And so just by shifting to a customer that was not satisfied with the status quo, we were able to get more traction than if we went to construction where we said, hey, we've got some incremental improvements that you can make. And they're like, yeah, but our customers aren't really complaining. Yes, this would be nice. We want to be innovative. And so there are companies that are talking to us in construction that want to do these innovative things and want to put out new products and be the market leaders, right? Be the ones that are setting the trends. It's easier for us to penetrate oil and gas because there are many companies that are having problems with durability, with maintenance, with downtime, with efficiency, with leaks. We can handle all of that from them.
You know, it's interesting you should mention oil and gas. I had a chat with somebody who runs a company in Houston, was in the oil and gas space like 2 weeks ago. It was a great, I really enjoyed the conversation because I know nothing about oil and gas as well, right? So it was actually a very interesting chat. And some of what you mentioned there is something what I think Steve had touched upon during that call as well. Okay, so let's talk about some of the things you mentioned there, right? Hiten? So you talked about, identifying those pain points and addressing those pain points. One of my initial questions is, do you go horizontal or vertical? What I mean by that is, do you pick an industry? Because you gave an example of construction as an industry and then oil and gas. You're like, you know what? That seems like a better place to spend your time and energy. There's limited resources, especially if you're a startup, you want to make the best out of that runway. So you pick an industry. Is that usually the way you would go about, either you or folks in general? Or are there scenarios where you would actually identify problems? They could be industry agnostic problems. Let's say one of the things we do at Sonpal completely differently is build APIs. Our APIs are not industry specific, right? They're domain agnostic. Anyone who wants to build software, we say can use our APIs to do whatnot. But we are also working on, say, a fintech API specifically for the finance industry. So there are some decisions that go into deciding whether I want to go with the industry or I want to go with the problem. But given that you have, hardware, it takes a lot more time to make it than something that's done over the weekend. Which of these typically makes sense?
That's a great point. I mean, that relates to like humanoid robots, for example, right? Companies that are building humanoid robots are going broad, right? They're going horizontal. They're not going vertical. And that's an interesting approach. When I joined Rise, our approach was also horizontal. There are all these sectors we can make a difference in, right? Let's go talk to them. And so it made sense for me coming on board as a new CEO. And one of the things we did was to really go horizontal and identify what was out there and to also connect with various kinds of customers. We launched our second generation cylinder. It's a standalone unit. Before I joined, we didn't have a standalone unit that we could really ship to anybody. So we created a second generation cylinder that's manufacturable, that's lower cost, that uses more off-the-shelf components, that is easier to manufacture. It's all of those improvements that you make from a first gen to a second generation design. And we launched it at Bauma in Germany. Bauma is the world's largest construction show. And we had over 200 leads from that show. So we went horizontal in a big way. Like we showed a lot of people, and certainly there were companies that were doing construction, but there were also distributors who were selling into different places. There were ag tech companies who were there, and so on and so forth. And when we came back, we had to decide from all of the folks that reached out to us, who do we really want to pursue? And so we'd spend some time understanding the problems of each of those folks. And as we did that, we started to get a sense of, okay, what's the problem they need to be solved, and where are we? And can we find customers that can meet us where we are? And when we discovered the oil and gas vertical, it became very clear to us that going broad made sense until we found a vertical that was compelling. And at that point, we could stop going broad and we could focus on this one vertical. Now, certainly there are customers that come to us and say, hey, I'm willing to do joint development because I have a pain point that you may not prioritize, but I would like you to prioritize. We'll do that. But when it comes to where we put our own chips, we're going vertical in a space that can meet us where we are, and we know that we can sell into that space with high margins, right? So if I was building, for example, humanoid robots, doing this broad thing and talking about the consumer market and all of this stuff, to me doesn't make sense because consumers really don't have the money to buy humanoid robots at this point, and the safety challenges are very high. But if you were able to find a specific use case where someone said, hey, I want you to build me a custom humanoid robot that can lift 200 pounds, works indoors and outdoors, can climb stairs and moves at such and such speed. I'm going to buy 10,000 of those. Well, you should jump on that and focus on that market as opposed to trying to build something that's super general purpose. Even if you have to give up, say, one arm, you have to build something that's custom that looks like a cyclops. It doesn't really matter as long as you have a customer where you can be successful. And so that's what we've done, is we've decided to start horizontal till we identified those vertical segments that made sense.
How do you draw the balance, Hiten, between doing something that's super exciting and very futuristic versus something that's meaningfully small and sizable enough so you can actually chug along? And here's what I mean by that. Different people have different luxuries. Elon's been saying that people can buy $35,000 humanoids and they're going to sell 1 million of them by the end of the year. But usually his timelines are, as we've known from history, sometimes a little bit off, right? But let's say that's excitement, right? You see excitement when you hear Elon talk or write, whether you like him or don't like him, there is that excitement, and he has the money to back that excitement. And I'll take another example, say Zuckerberg, right? With Metaverse, which I think they've finally dumped after many years. I think Reality Labs spent about $80 billion. It's because I'm sure Mark, as somebody who started the founding engineer of the company, had to want to do something cool and fun. So they had this baby, but the baby did cost $80 billion and it didn't go anywhere. But those large hyperscalers have the luxury of making these mistakes, not one, not two. I mean, you take all of these companies, there's a graveyard of products that never shipped or did not make money. But as smaller organizations, I always wonder, personally at Sonpal, for instance, we don't have the luxury of making 17 mistakes before getting it right the 18th time necessarily, because people are going to judge you all the time. So as a startup who's in this exciting space of robotics, how do you draw the parallel? Where is that line between, hey, this is what Hiten wants to do because it's super exciting. You wake up in the morning, I'm going to build this thing and it's really cool, right? This cylinder is the coolest one. But then you got to make some decisions and say, let me build the cylinder that's not the coolest one, maybe, hypothetically, but it's something that the industry needs. It's something that your customers need. Is that a problem that you run into in the space that you're in?
Well, yes and no. Personally, I'm excited by two things. One is building high-performing teams, and the second one is shipping product, right? And so to ship product, you only need two things. You need to have a product that you can ship, and you need to have a customer that wants to buy the product. And so the goal is, how do you marry those two together? One of the things I did when I joined Rise is to put a few values in place for the company. The first value, of course, was safety, because we were working with things that are big and heavy, and we want to be safe for our employees and we want to be safe for our customers. But my second value that I instilled in the company was customer focus, which is, if we're going to transition from a tech and development organization to a product company, then we really need to think about what the customer wants and use customer pull as a way to win and as a way to advance the business. So for me, it's been very natural to kind of align myself with customers, and that's one of the reasons why the founding team brought me on board, because they saw that I was an advocate of finding customers, solving customers' pain points, not necessarily focused on what is the coolest thing we could be doing.
And your products, are they AI native or are they AI assisted? And here's what I mean by that, which is, can your products and components work without dependencies on AI tools, or do they need them at their core to actually be functional?
Yeah, we are AI enablers. We don't really have AI inside of the actuators, and we don't need our customers to use AI tools to build, for example, a drive-by-wire system. If they choose to add semi-autonomy and teleoperations and full autonomy, they can do that with our systems. Our systems enable that, but are not really dependent on that in any way.
Innovative fundraising. You mentioned it just before we hit record. So just tell us what were some of the challenges of raising money to be able to doing this, and what do you mean by innovative fundraising?
Yeah, so when I joined Rise Robotics, it was an interesting time where there was a lot of interest in humanoid robots, and there was a lot of interest in AI, and VCs that I spoke to plan out our next round didn't really want to give us great terms because they had so many deals available in the hardware space, and they really were their LPs were looking for exposure in humanoids and AI systems and so on. And so one of the things that I noticed about Rise is that we had 1,500 followers on LinkedIn, And when I asked Aaron, the previous CEO and one of the co-founders of the company, why we had 1,500 followers, he said, well, folks that find out about Rise usually ask us how they can get involved, and we just tell them follow us on social media so that we can give them updates. But oftentimes they're looking for ways to invest in the company. And so that gave me this idea of using crowdfunding. There were a couple of companies that I was advising that had been successful raising money using regulation crowdfunding, which is this law that was passed during the Obama administration that allows startups to raise up to $5 million over 12 months. And since we had all of these followers that had expressed interest in wanting to participate in some sort of way, I thought it would be something that we should try. So we did what's called a testing the waters campaign. We opened up a sort of an interest round where people could express interest but didn't have to commit any money under the same terms as our previous institutional round. And within a month or so, I had $800,000 of interest from people. And so I was like, oh, there's some interest here, so why don't we kick it off? And so we then turned that into a real campaign, which we ran on a website called WeFunder. If you're doing RegCF, you have to use an intermediary platform. The intermediary platform makes sure that companies like us file all the right disclosures, and then they make sure that they make all the investors aware of all of the risks. So we use this platform called WeFunder, which is the #1 crowdfunded platform in the world. And to our surprise, last year we raised $5.7 million. Well, we had $5.7 million of reservations. We're only allowed to take $5 million. And I'm still trying to find ways to get the $700,000 worth of investor interest that we weren't able to take last year in this year. So we'll be opening up another round. And we're really excited that there was this much interest. Just completely surprised because we're a B2B company. But I knew that we were kind of in an interesting phase in the company's life. We were going from pre-commercialization to commercialization, right? And there's a lot of stuff happening there. You're talking to customers, you're updating hardware, you're running pilots. These are all things we could report to investors. And so investors have been able to follow our journey and see as we go to shows, as we show off the tech, as we get results from our pilots, and as we land more and more customers. So it's kind of an exciting time, and it's been great having, now we have 25 investors. It's been great having these 25 investors in our corner. These are folks that introduce us to other investors. They introduce us to potential customers. Some of them want to be our customers. Some of them want to be our suppliers. It's been incredible. Just something I didn't expect.
Amazing. Talk about crowdfunding a little bit more. I looked at it a little while ago. So tell me, with crowdfunding, Hiten, are people who are investing in the company, whatever amount of money they end up investing in, are you able to give ownership, like a percentage of the company? Because when I looked this up a while ago, it actually said that we can give them credits, we can give them offers, but we could actually not give them a piece of the pie as equity in the company. But with this crowdfunding that you mentioned, do people who invest, do they actually get equity in Rise Robotics?
Yeah, over the last few years, the whole process has advanced to the point where it's become very transparent and very understandable. What happens when you run a crowdfunding campaign is that an LLC ends up owning a chunk of the company. So there's an LLC that owns $5 million worth of the company because they're putting that much money. And all of the investors end up owning a piece of the LLC. So it's very straightforward. And the reason why this is done, why there's this two-layered approach, is that as companies raise their future rounds from VCs, a crowded cap table is very complicated to manage. And so this way, we just have one line on the cap table for our 2,500 investors, and it's super simple, and it allows us to take very small checks. So the minimum investment that someone can make in Rise Robotics is $250, right? Anyone can participate. And what we like about this is, as you know, for example, from the SpaceX IPO that is being rumored, right? They're gonna IPO at, I don't know, 1.5 trillion, $2 trillion, right? Yeah. Well, I don't know how much bigger that company is going to get. And what that tells me is that most of the money that was going to be made on SpaceX has already been made. Companies are staying private longer and longer, and early investors are exiting to later investors in private markets before it even hits the public market. And now that it's hitting the public market at $2 trillion, I don't know how a retail investor is going to make money on that investment, right? When you look at data centers in space, and there's just so much that SpaceX would have to do to justify that valuation even today, never mind in the future. Whereas companies like ours and other companies that are not yet public offer retail investors an opportunity through Reg CF to get in early, just like the institutional investors are getting in. And one of the reasons I think why our campaign had so much traction is that third parties that were looking at our offering saw that the terms were very similar to what we had offered to what we had offered institutional investors, and we got very high ratings. So there's a company called King's Crowd that rates all of the crowdfunded offerings that are out there. They gave us a 4.7 out of 5 stars because the shares we were offering, the terms we were offering them under, were all things that typically only institutional investors get, and now retail investors were getting it too.
That's actually, thank you for sharing that, because that specifically is going to be helpful for not just us at Sonpal as startup, but I think a lot of people who I talk to and who are listening in as well. Hiten, with the world changing at a rapid pace, more people are want to realize their dreams that they put away for a long time, either because they have to do it because companies are restructuring and there's not a need for that many humans anymore. So people are quote unquote forced into realizing their dreams in a nice way because they lose their jobs whether they like it or not, and then you have to now become an entrepreneur, and people are looking for different ways to start doing things that they've been wanting to do for a long time. So definitely appreciate you sharing that.
I want to add one thing too, is we also get impact investors, right? So some of the products that we're selling to the Pentagon actually improve the lives of folks that are defending the United States. So they don't have to, with our tech, they can stop inhaling diesel smoke. They can stop being around loud equipment that impacts their hearing. They can stop leaking hydraulic oil into bases, which eventually turn into Superfund sites, right? So all of those things that we're doing actually improve the quality of lives of people. And so there are folks in the armed services that have worked with hydraulic equipment that see our tech and it's like, oh yeah, I work with that piece of equipment. I love what you're doing. I'm going to make an investment. And then there are folks that really like the climate angle, and then there are folks that like the clean angle. So we're getting impact investors, but we're also getting, white collar professionals that look at the opportunity and say, oh, this is great. These guys are disrupting something that is in a big market. Like we're operating in a $750 billion market when you take mobile hydraulics and you take industrial hydraulics. And so big markets are typically things that institutional VCs also look for. And a lot more of these retail investors are getting savvier and savvier about the investment they're making. And they're starting to think like VCs, which is, hey, for this company to explode, it has to be in a big market, and we are in a big market. So there are all these other reasons why I think folks are also investing in Rise.
Wow, thanks for sharing that. Say going out to dinner, you can pick the place you're going to. It doesn't have to be the same cuisine, but can you give us what your order of appetizer, entree, and dessert might be? Just one dish.
So for an appetizer, I'd probably like a tuna sashimi. For the main course, I'd like some kind of duck dish, because duck is definitely my favorite kind of meat. And then for dessert, I'd like ras malai. This is an Indian dessert made out of milk and cheese, which has been my favorite for a long time.
Thank you. Of the three, I'm vegetarian. I don't understand the first and the second one, but the third one I certainly do, and I totally love that. So thank you for sharing that. Again, Hiten, thank you for taking the time to educate not just me, our audience as well, about many things, hydraulics and hardware and whatnot. Certainly appreciate your time here. Before we call it done, do you want to just have a closing comment to our folks?
Yes, this was incredible. Thank you, Krish, so much for having me on the podcast and asking me these questions. They were certainly ones that made me think, since other podcasts have not asked these questions, including the one about my choice of meal. The one closing statement I'd have is if folks are interested in checking us out, they should go to our website, www.riserobotics.com. And if they're interested in investing in the company, they should go to invest.riserobotics.com. We have a campaign page where we describe what we do and why to invest in the company. And then there are also investment memos written by a couple of VC firms that have invested in us that explain their assessment of our risk and reward, and they're independent third-party reports that they can look at. So they don't have to rely on me or make or their own judgment. They can really hear what other people have had to say and then make a decision.
We'll certainly do that. So we'll include the link to your LinkedIn profile, and then I have your Instagram here as well, instagram.com/Rice Robotics. And you said the page folks have to go to is invest.ricerobotics.com, correct?
That is correct. Yes.
Perfect. We'll certainly include that. Folks, I think that's essentially it. One more time, we had a chance to talk to Hiten Sonpal. Hiten is the CEO of Rise Robotics. We talked about many different things. Quickly to summarize, how to build what building deep tech taught Hiten about product development, how to bring hardware innovation into legacy industries, what startups tend to get wrong about scaling complex tech, last but not least, about crowdfunding and innovative fundraising. Thanks so much, Hiten. Appreciate your time.
Thank you, Krish. Bye bye.